Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at core practices and TI technology. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight I'm excited to be joined by our two panelists, Denny St. John and Doug Lapp. Denny is a T-Cube national instructor, holds a PhD in mathematics education from the University of Iowa, a TI-inspired technology online course creator and curriculum content author. Denny currently teaches mathematics and mathematics education at Central Michigan University. He is in his 33rd year of teaching. So Denny, it's great to have you with us tonight. And Doug is a professor of mathematics and mathematics education in the Department of Mathematics at Central Michigan University as well. He teaches undergraduate mathematics content courses, courses for pre-service secondary teachers, and graduate courses in collegiate mathematics education. Outside of CMU, Doug is the 2020 recipient of the Michigan Mathematical Association of America's Distinguished College or University Teaching Award. So Doug, congratulations on the award, and it's great to have you with us tonight.
Great to be here.
We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Dennis or Doug using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the very top of the WebEx menu and choose Audio Broadcast. So Denny, I'm going to give you control. Feel free to share your screen.
Hello and welcome to our session. Tonight's session is about core practices of instruction utilizing Texas Instruments technology. Doug and I have been at Central Michigan University. I've been here since 1993, and Doug's been here since 1998. We're best of friends, and when I had this opportunity to talk, I knew I wanted to do it with Doug because what he has to chat about. Hello? What he has to chat about is valuable for all of us. And it adds to this notion of core practices. And he's going to be chatting about active learning. But because of this webinar, you should be able to describe two key aspects of the core practices and describe characteristics of active learning. And we're going to examine the power of combining active learning pedagogy as well as the use of technology. Okay. So what are core practices? These core instructional practices, these core practices are now taught to pre-service teachers at over 140 institutions. In Michigan, they're called high leverage practices, but core practices are a practice that is deeply linked, directly linked to deep and usable learning, and directly helpful in instruction aimed at helping students learn content in deep and usable ways. Now, I'll be talking quite a bit about teaching works at the University of Michigan. They call the core practices high leverage practices. So I'll use those terms interchangeably, but Stanford, University of Washington and Washington State, and the University of Pennsylvania, and these other 100+ universities are now utilizing these core practices. In the state of Michigan, there are 19 of them. In other institutions, there are as many as 75. Different institutions have a list of these practices that they want beginning teachers as well as practicing and growing teachers to be able to utilize to help students learn. And it's directly linked to deep and usable learning. What does that mean? Well, there's evidence that a particular practice helps students learn. And deep and usable learning means the development of worthwhile knowledge and skills and the ability to use what is learned for their own purposes, to provide opportunities for agency. So Doug will mention a little bit of evidence about this, and I don't mean that there's a little bit, but he'll talk about that for a short time. Okay. Now, what do we mean by directly helpful in instruction? This practice is necessary to designing and implementing instruction so that students learn content in deep and usable ways. Again, deep and usable. Examples that teachers need to utilize are eliciting and interpreting individual students' thinking, leading groups discussions, and there are several others. I'll show you the list in a little bit. Now, throughout this practice of developing practices for pre-service teachers who become practicing teachers and professional development opportunities for practicing teachers, these core practices were built upon the ideas of providing equity and justice. That's the hallmark of the core practices, to help all learners grow. So, the foundations for these HLPs, or core practices, include having students learn worthwhile content and skills. Again, to learn to use this content and these skills for their own purposes. We don't know what those purposes are most of the time, but to develop power, we need to shoot high. Number two, that they need to learn at a high level. We also need to recognize that learning is an active sense-making process, and teaching is interactive work, co-constructed with students, and the context of the classroom teaching matter, and the teachers must manage and use them well. The second, third, fourth, and fifth items on this list scream at me active learning environments. So here are the 19 practices in the state of Michigan, and our state has adopted these as goals for teacher education units to provide instruction, and the state of Michigan is requiring 5 of them to start with. And I'll read just a couple of these. Leading a group discussion. Beginning teachers, practicing teachers need to know how to do that. They need to explain and model content and practices and strategies. They need to know how to do that well. They need to elicit and interpret students' individual thinking. And the list goes on. These are the practices beginning teachers need to have. The last one in this particular column is building respectful relationships with students. Not just friendly relationships, but intellectual relationships that all of your students, believing all of your students, whether they're pre-service teachers or kindergartners, are intellectual beings, and they're capable of developing powerful ideas with you, your guidance, and with other students in the classroom. So, choosing elements of practice that are important for most beginning teachers, and let's face it, all of us can develop finer and finer skills if we decide that that's what we're going to try to do. So the beginning practice list is what teachers need to know how to do the first day they're on the job. We don't want them to do harm. And they cannot be done for them by some other school professional. They have to be a task that they have to know how to do. So if it's something that's too complicated, it wouldn't find its way on the core practices. It would find its way on exemplary practices or advanced practices. They have to be useful across subject areas, grade levels, curricula, and instructional approaches. So we have some common vocabulary. And the criteria for these in teacher education, and I want to bring up this idea right now. Everybody who works with students, who works with people who want to become teachers, like practicum students that come into your classroom, people doing a mid-tier experience where they might get to teach a lesson, teacher coaches, teachers working with student teachers, professional development practitioners. When you provide professional development for others, these teachers, you're giving them an opportunity to grow. So because we're all teacher educators, these beginning practices need to be unpackable. We'll talk about what that means in a moment. And they need to be generative of additional learning and skill development. One can see the generation in the next slide. And these things can be assessed. So here's my first example of this idea of unpacking. If we had to explain and model content means to share your thinking about how you would solve or do something. Explaining, just tell people what to do, how to do it. But modeling includes your thinking aloud of what you're doing and why you're doing it and how it will move things forward. But this is a visual representation of how to break it down, how to unpack it, called a decomposition. So we have one part here, planning to model, and underneath it there are some pieces. Then we have the actual inaction of the modeling and doing this as we go through things. I know my pre-service teachers have difficulty framing because they don't know how things fit together in the big picture like teachers who have some experience. And closing is an opportunity to tie some ideas later on to content that they'll see sooner or later. This is a little bit more complicated. Each decomposition at the University of Michigan's website, teachingworks.org, has that visual. This is now the textual one, and it comes at us in tables. And this one shows the steps. There is a visual for this one as well. But when you're eliciting and interpret student thinking, you need to formulate and pose questions that you plan to ask and probe students when you work with them either individually or as a class. And you need to develop that sensitivity to how students might respond or hear this. The second phase of this is listen to and interpret. That's in the now when you're teaching or doing the eliciting and interpreting. And then you also need to have additional questions that you develop on the fly as well as ahead of time for follow-up and closing. So these unpacking, these decompositions, there are 19 of them available on TeachingWorks. So you probably know this cycle. It's practice-based learning cycle, but it could be named by other places as something else too. But learn the practice, learn what that's about, plan to do it or practice it in a situation like role plays, simulations, etc. Then you go out, you teachers out there, you have rich opportunities to enact these things, to try them out, then reflect on it. But this could be done in a PLC, It could be done with your teacher candidates that you're working with. It could be done with a colleague to go through, learn about a particular practice that you want to get better at, then approximate it, enact it, reflect on it, and then go back again to see if you can refine it. This cycle is core to all the core practices across the U.S. So Doug's going to take over with active learning. I believe that the combination of an active learning environment and the core practices allows us to get at more core practices when one engages these core practices in an active learning environment. They come in clusters. And so Doug's going to take over from here.
Thanks, Denny. Denny's going to pass me the ball here.
You hope so.
There we go. All right, thanks. Let me share my screen here. All righty. So what I'm going to talk just a little bit about, I'll get through these slides very quickly and kind of get to the meat of the idea and the activity here. But the big question is, what is active learning? And in general, active learning is a pedagogy that engages the students as active participants in the learning of the content during class time. And this is one of the key things. We often expect students to get together and work on projects and things outside of class, but active learning pedagogy really says, let's reserve the class time when we're all together for discussion and debate. And so I want to highlight that part. Students work collaboratively during class as well as outside of class. The teacher is available during the class to simply act as the orchestrator of the discussion. So it's not like the teacher doesn't have a role, but you want to turn as much autonomy over to the student as you can. It can take the form of short activities or longer labs or project-based investigations, and the students participate in the decision-making that happens in the classroom. It's not just the teacher saying, let's do this, let's do that. One of the reasons you might ask is, why do we care? Well, the meta-analysis that Freeman and others did in 2014 looked at 225 research studies that used active learning pedagogy, and on average, student performance increased by just a little under a half a standard deviation when active learning was used compared to lecturing. And on average, traditional lecture courses were 1.5 times more likely to fail than students who were in an active learning classroom. So average failure rates were about 21.8% under active learning and 33.8% under traditional lecture. So this difference is substantial. So we want to really try to take that into account. So one of the big things that I hear from a lot of teachers is, ain't nobody got time for that. And there is some legitimacy to that, but I think sometimes it's short-sighted in that we actually pick up time. We actually gain time when we allow for this, because when deep learning happens, as a teacher, you need to do fewer examples. You need to, you don't have to repeat yourself as often because the students are engaged in the content. And actually, this happened just the other day, actually. I was teaching a Calc 1 class, and we were doing both remote and in person here because of COVID. And in the middle of the class, we were doing this activity, actually, this one right here that you can see in this image. Students were actually projected a GeoGebra applet, and they were trying to give each group took a point, estimated the slope, and then we used points to drag into place to try to see how good our, quote, slope function was based on that. And in the middle of this, I heard in the background from one of my remote students, I heard this, and I'm like, okay, is everything okay? And the student said, you know, I took calculus before, but I never understood what a derivative was. And there was this aha moment because the students themselves were actually engaged in collecting the data, creating a plot, so they actually understood what those points represented. So one of the things that I want to point out here is we pick up time when we allow students to be engaged in decision making and actual data collection because they know what it is we're trying to say. So the teacher serves really as a facilitator of this course, but the drive comes from the students. And the teacher acts to summarize class observations and the arguments. This can take place both inside class and outside of class. For example, I could stand at an overhead or a visualizer or a document camera and recite or write down a definition or a theorem or prove something all I want, and the students are frantically trying to copy that down and get it down while they're in the classroom. But if I allow the class time to be spent in discussing and noticing the patterns that lead to the definition or lead to the theorem, then I can put off to outside of class the formal definition or the formal proof of a theorem by using a video. I can do a screencast of me defining or proving and narrating it, and then they can watch it as many times as they want. They can rewind it, watch it again, as opposed to just trying to get everything down because they're afraid they're going to miss something during the class time. So we take that precious class time when we're there to debate and discuss mathematical ideas, and we treasure it, and we put off the boring stuff that I'm going to do as the teacher for outside of class. Use that as the place to summarize. So now the question is, how is active learning environment related to what Denny was talking about in core practices as we think about preparation of teachers? One of the things I really want to focus on are the two things that Denny said. One was that we want students to use what they learn for their own purposes. Okay, this is at the heart of student autonomy in the classroom. And that we also want to engage them in active sense making. Okay, you can't actively make sense of things if you're not being posed questions or you're debating with your fellow students about ideas. So the practices that I think of the 19 Denny was listing that are probably the most relevant here inside this kind of active learning classroom would be things like leading a group discussion, eliciting and interpreting individual students' thinking, because as a teacher, I need to be able to listen to what they say, I need to be able to understand what they say, and I need to kind of farm that out to other students in the classroom to make that discourse visible. I want to implement norms and routines of how are we going to interact with each other, how are we going to be respectful of each other's thoughts and ideas. How am I going to coordinate and adjust my instruction during the lesson based on the student feedback? It may very well be that a student goes down a path I wasn't anticipating in my lesson plan. So I need to have the flexibility to be able to adjust my lesson on the fly so that it's clear to them that I value what it is they said. I want to be able to specify and reinforce the productive student behavior, and I want to minimize the unproductive student behavior in the classroom. I want to be able to implement organizational routines. How is my class going to run on a regular basis so that I'm training the students when they come in, they know what it is they're supposed to do, and they get to work. I want to be able to set up and manage small group works. For example, I want to make sure my groups are productive. Typically, if I've got a group of 4 students, I want 1 high achiever, 1 low achiever, and 2 middle achievers. The 2 middle achievers typically act as the translator between the high achiever and the low achiever. So what we know from research is that group construction is crucial for not having dysfunctional groups. I want to build a respectful relationship, is what Denny talked about earlier. I want students to know that I'm part of the team. I'm not simply the authority figure. So when I wheel around in my chair from table to table, I actually wheel in my chair down at their level. So when I wheel up to their table, I'm literally eye to eye with them. I'm not standing over them. And even those subtle physical proximity types of behaviors sends a very subtle message to the student that I respect them and I'm with them, I'm one of them. And I want to be able to check for student understanding at the conclusion of a lesson. So I might use an exit ticket, I might use some sort of quick poll, whatever, to evaluate where we are. And I also want to be able to select and design formal assessments as needed. But one of the big things is providing oral and written feedback to the students. In the active learning room, oral feedback is crucial because what I want to be able to do is have discussion and have the students share their ideas freely without fear of making mistakes. In fact, at the beginning of every class, at the beginning of the year, I start with a clip from Won't You Be My Neighbor, the Fred Rogers video, documentary one, not the Tom Hanks one. About an hour into that, there's a 3-minute clip about making mistakes. And you'd be amazed at how many of my students came up to me after that first day and said, thank you for playing that because it really made me feel like this is a safe place. So providing that, that environment where students can learn and share ideas is crucial. So what I'm going to do now, let's be done with the slides and let's go and play a little bit. So I'm going to look at an example from an active learning class. This particular class was an intermediate algebra class. We were studying parabolas, and I'm going to describe what's in a PDF that I call Home Run Derby. But in reality, when I actually did this, there wasn't a pre-written up activity. I converted it into a guided discovery activity after the fact. But in reality, what it was is we were going to play a little game. I actually had a fair number of football players in this class, and we were talking about who could hit the ball the furthest. So we decided, hey, let's go outside and let's hit some balls, and let's see if we can figure out a way to measure the distance without actually having to find where the ball finally lands, getting a trundle wheel or a tape measure, and instead we just have a single meter stick, and we want to be able to model it and then use that to make conclusions later on. So this is a picture of some of the students. We let anybody who wanted to hit. So I've got students, I've got a gal back here, if you can see this, she's holding a meter stick in her hand, and that meter stick is what I'm going to be using to set the scale of this particular video. So I had my phone, this mounted on a tripod, and we conducted video. And of course, this is the old man right here getting ready to hit, which is actually kind of funny because when all was said and done, the old man's the one that hit the ball the furthest, hit it further than some of my football players, which was kind of funny. They didn't think I could do it. So, so here's the, let me show you so I've got a little short video clip. And in the activity that I got here to share the PDF, I've got a couple different ways that it could be done. One is using software called Logger Pro. Many high schools will have this because if you have a physics class, chances are Logger Pro and Vernier probes are probably used by your physics teacher or your chemistry teacher as well. So you probably have a site license for the software. And there's a video analysis capability of it. And I'm just going to demo that just briefly with you. It's kind of a, let's see, oh, this is just the video. Okay, let me find the Logger Pro, there it is. Okay, so here I've actually inserted an axis system, and I can advance the thing frame by frame. You can see the ball coming in here. I'm getting ready to hit it. Okay, so right there is when I hit it. And so I put my axis system through the ball right here. And now I can actually advance this frame by frame and put a data point at each location. So I'm going to click my little data point here. And by the way, you'll notice now there's a green line here where the meter stick that she's holding is. That's because I measured that to be 1 meter. And so now that's defining this. Now, out here, we had to actually have a discussion in class. So this actually came before we went out to the field. What happens if I hit the ball and I pull it to left field or I push it to right field? Well, it's going to be hard for us to evaluate the path of the ball from the video because we're not all hitting on the same plane. So what we did is we took a couple orange cones out, and back here behind where the pitcher is, we put the orange cones about 10 feet apart. And so when we allowed people to hit, the only hits that we counted were ones that if you looked between those cones, the ball landed, so that we were all pretty much hitting along the same plane for the most part. So it's the best way we could do to have a fair analysis. And so this discussion happened in the classroom before we went outside. So a lot of this is coming from the student. Okay, so again, this is more inquiry oriented. It was not a written up lab. So now what I can do here is I can get on top of the ball and I can click it, get on top of the ball again, click, on top of the ball again, click, On top of the ball again, click. On top of the ball again, click. 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 And I can do this as many times as I want. And there the ball goes. Now, what I can do, let me shrink this guy down just a little bit so you can see. Shrink the video down. And now you can kind of see both the x and the y coordinates plotted as a function of time here. But in this particular case, we were trying to figure out what the range was. So what we're doing is we really want the y coordinate on this axis. So I can select that. And I want the x coordinate on this horizontal axis because I really want the physical path of the ball. And now we can analyze this a variety of different ways. We could do a curve fit. We can, pick a few points and try to analyze them from a few points, and so on. And so there are multiple pathways to doing this analysis, and you can see the data points up here. Now, I'm going to kind of move out of this and just talk about what you could do if you didn't have Logger Pro. I've actually created a still image of this situation. Down. And I've superimposed it on my screen here. Let me step out of the way. So I've actually imported the image, the still image that has the trail of the softball into the TI Inspire. And so I made sure that I put tick marks in here that's equivalent to the 1 meter stick that she is showing. And then we can now put points in here and analyze it a variety of different ways. We could do it using a regression, which is probably the most typical one. But in this particular case, because this was an intermediate algebra course, I wanted the students to look at developing parabolic models based on different numbers of data points. And so one of the things that we know from 3 non-collinear points, we can define a unique parabola through it. So that's one of the things I wanted them to explore. So what I'm going to do now in the Inspire is I'm actually going to, and again, we did this once we were in the classroom. We analyzed all of our videos. I've got videos from a lot of these different students, but I'm using mine because I hit it for this. No, because I've got permission to use my own data.
Give yourself permission.
Give myself permission. So what I'm going to do is I'm going to put a few points here. So I'm going to click Menu. I'm going to go down to Geometry, get my points. And I'm going to put some data points on here. So I see one there. So I'm just basically putting points in here, covering up some of these little blue dots. Okay, so I've got 3 points there. Now, I want to be able to see the coordinates of those points, so I'm going to go in here, and I'm going to go to Actions. I'm going to go down to Coordinates and Equations, and I'm going to point at the points. Click. Move that over here. Move these out of the way a little bit. Point at this guy. Click. Move him out of the way. Point this guy, click, move him out of the way. All right, so now I've got some data points here that I can actually work with. So one of the things I want to do now is to try to use these 3 points to find a unique parabola through them. The nice thing about the Inspire is I've got the ability to define things and then operate on them like they're objects. So I'm going to add a page. And I'm going to add a calculator page. And again, a lot of this is in the guided discovery version of this activity that I've got written up as a PDF. But again, here, remember, inside the classroom, we were actually having discussions where the students were trying to decide what it is they wanted to do. Okay, and so we're going to define, I'm going to go to menu 1, 1. I'm going to define a polynomial, p of x equal a times x squared plus b times x plus c. So there's my parabola. And now, if I want to find these parameters a, b, and c, I can do so by solving a system of equations. Okay? The nice thing is I've got this defined, so I could call p by its name, and I don't have to retype everything in every single time. So what I'm going to do is I'm going to set up a system of equations, and I'm going to use these inputs and outputs to develop the equations that I'm going to solve. So I'm going to go to Menu, Algebra. Go down to Solve System of Equations. Okay, I want to have 3 equations, and I'm going to have 3 unknowns. I've got 3 data points. My unknowns are A, comma, B, comma, C. And so now I'm just going to say P of, now let me go get a data point. Let's get this guy. Okay, I'm going to do Control C to copy it. I'm going to pop over here. I'm going to do Control V to paste it. Equals, so that's the input. Let's go get the output. Click on that coordinate. Again, Control C. Pop over here. Control V. And there's one of my equations. I'm going to do the next one. Again, pop over here. Grab this coordinate. Control C. Pop over here. Control V. Go grab the other Y coordinate. Control C. Control V. And one more to go. Control C. Control V. And lastly, is anybody asleep yet? Control C. Control V. I try to get my students used to the idea that they can grab things and manipulate them around the screen, because I really want them to realize that we're working in a kind of a little micro world here where we grab things. We don't have to retype everything in, because chances are we'll make a mistake when we retype. All right, so now if I solve this system, I get values for my A, B, and C. And if I actually want to see what that polynomial looks like, I can say type P of X, and then I can make the temporary substitution for A, B, and C here by doing Control equals and getting my such that key. So it says such that, and then I'm just going to hit my up arrow, grab that whole string of stuff, A equals this, and B equals this, and C equals that, and hit enter, and now we can actually see it. So now if I want to go over and I want to see what it looks like in terms of my data, I can go up here and grab it. I'm going to do Control C again to copy it. I'm going to go over to my graphs page. Just going to double click here to pull up my function registry. I'm going to paste it. So Control V. Again, I grabbed all that. I didn't have to type it all in. I'm pasting it. And I hit enter. And we can look at this, and when we look at this, one of the things that students will often notice is they'll say, it looks okay here, but look, it's veering off a little bit. So I'm starting to veer off. Well, in the discussion we had about this, one of the things that one of the students mentioned was they said they think, well, what if the points are too close together? So I said, okay, let's deviate from that. I can grab this point right here and move him. And I'm going to put him out here at that location. And notice that it updated my coordinates automatically. And so now I can go back over here and edit that. So if I go up, I don't have to retype everything. Again, I want them to get used to grabbing things. So I'm going to grab that, and I'm going to come in here. I'm going to delete this point because I changed him. And I'm going to go over here, and I'm going to grab this new x coordinate and do Control-C. I'm going to go over here, and I'm going to do Control-V to paste the new one in. Okay, I'm going to edit this guy. I'm going to go back over here, grab his y coordinate, Control-C, and Control-V. Okay, now I just recomputed it. And if I, again, want to see the entire expression and graph it, I can use my such that key, grab these guys, make the substitution, go up, copy, Control-C, hop back over here. Let me edit function 1. Delete that guy. Oops. And paste the new one in. And hit enter. That's looking a little bit better. And so what we did in the class is we actually debated how we're going to determine the best model. And so I let them play around, and the different students came up with slightly different models. And then we actually looked at things like, for example, how are we going to determine how far I hit it? And so I had put them in their groups, I let them discuss it, and they said, well, we want the height to be 0. So that thing that normally we tell them, they actually came to that conclusion on their own. They said, well, we want to find out where the y coordinate is 0, and so they can go over here and say, all right, let's go down here and solve. F1 of x equals 0, comma x. And then they get the answers that they came up with, in this case, about 30 meters. Okay, so again, different ones had different outputs depending on which points they picked. And so we had to have a debate about it. And so the conclusion basically is let's actually look at the, it's the old, let's lop off the German judge. And so we lopped off the high end one, we lopped off the low end one, and they decided they wanted to average the ones that the individual groups came up with for each of the models that they picked. So again, a lot of decision making went into the method that they chose. And I didn't tell them what was right or wrong. I just said, what do you guys want to do? And I left the autonomy up to them. And so those are the kinds of experiences we want them to be engaged in. So again, this is just one example of a variety of different things that you can do to engage students in decision making. And that's part of active learning. I don't want to be the person telling them what to do. I want them to tell me what to do. Now, I may pose questions like, are you sure you want to do that? Have you thought about this? Have you thought about that? But ultimately, I want the decisions to come from them because that's what mathematicians do. And I want them to behave as mathematicians. So let me halt this right here. And I'm going to pass the ball back to Denny. And he's going to talk a little bit more about core practices. So let me mute. Denny's got the ball.
So that was Doug's example of Home Run Derby. He has a written PDF for you that has that as a guided discovery lesson. Changing over to an active learning environment is difficult. It's worth the effort, though. You employ so many different core practices when you engage in it. There's clusters of these occurring throughout an inquiry-oriented lesson as well as a guided discovery lesson. So, I'm not sharing?
Nope.
Oh. I thought I was.
Denny and I
Thanks,
are actually
Denny.
in the same room.
Perfect. Thanks, Denny.
All right. So some commentary about this set of core practices used in this active learning environment that Doug described. The only video we had was of him hitting the longest ball. But I would like for you to put in the chat room, type up some things that you think were part of the core practices or phrases that are associated with the foundations of implementing active learning environments or core practices. So I'll move to the next slide. Things to think about. You can simply send forward numbers for us. And here are the Teaching Works high leverage practices again. But if you'd share with us, please, the things you noticed in the chat, that would be great. And we can talk a bit about that. One of the practices that Doug described.
So I'm getting some private chats. I'll just share this with you.
Thank you.
Looks like Gerald and Dana both say 6.
So we're getting coordinating and adjusting instruction during a lesson.
Gary said 14 and 16.
So designing single lessons and sequences of lessons is a feature of this. There's certainly lots of use of the technology that required building capability over time. And the other one was 15.
Yep.
Checking student understanding during and at the conclusion of lessons.
I'm sorry, 16.
I'm sorry, 16. 16. Selecting and designing formal assessments for learning. Doug did mention that that was part of this environment. Now, not necessarily during the activity time, but certainly later for examinations, quizzes, and certainly in discussions that are held later on.
Looks like we're getting some other chats in. I see one from Michael. Michael posted a few that he thought he saw. Kathleen with, I think, 4. Okay.
So we have diagnosing particular common patterns of thinking and development in a subject matter domain.
Sorry, 4 different ones, 1, 3, 6, and 19.
Also, again, leading discussion, eliciting and interpreting individual student thinking, diagnosing common patterns of student thinking, and 16 is selecting and designing formal assessments again. So you're noticing in his description what kinds of practices even an expert would utilize. I always think of an active learning classroom and lots of practices that are being seen in the NBA. If you don't care about basketball, I'm sorry, not for you, but the idea is in basketball, before every game, they practice certain particular skills. And then they put them together, and usually in June, they start playing defense. But the idea here is these are complicated things that can be broken down and practiced by beginning teachers. Teachers have been practicing for as long as I have, 39 years. I feel like I grow every time I implement one of those cycles of learning. And so lots of these things occur together. One of the main ones, though, again, is eliciting and interpreting individual students' thinking. You do that when you have a discussion in class. You do that when you're sitting down with them working one-on-one. You do that with them when you run into them in the hallway. Eliciting is central to several of these, but the idea of asking questions and posing them, getting at their thinking to push them forward is a wonderful practice to have under control. So, now, curious about questions you might have. I skipped over that slide in case there are questions about modeling. There are two different kinds of modeling we talked about today. Doug was talking about mathematical modeling that he did with the home run derby problem, but at the same time he was talking about it, he was sharing his thinking about how he engaged his class. So teacher to teacher, he's modeling how he worked through things and what occurred to him and how he either solved the problem, overcame an obstacle, or developed some group consensus. So please share your questions through the chat.
So we got a question from Gerald. Question is, what was the group size? And added that 4 shown in video.
What was the group size of the class?
Either the class or I'm guessing those that were grouped in the activity.
Yeah, class had, I think, about 23 students in it, maybe, something like that, 23, 25. I can't remember exactly, but it's been a couple of years ago that activity. It was, we basically all went outside, just like the whole class went out, and anybody who wanted to hit was welcome to hit. Nobody was pressured to hit, and so everybody else kind of was support staff, so to speak. So their people were out, shagging balls in the outfield and tossed them into the pitcher, that sort of thing. We spent maybe about a half hour out collecting video from whoever wanted to hit. And then when we came back in, I actually had the video on my phone, and so I just airdropped it to my laptop, and then we started looking at each individual video analysis of each individual student who wanted to participate in the game, so to speak. And it was kind of fun because, we had some small wagers going on as to who was going to hit it the furthest.
So Kathleen's asking, what active learning can you do virtually with your students?
Kathleen, there are a number of different things one can do, especially when you begin this opportunity to work with students in this kind of environment. Bringing them into the chat room is the beginning of having them share things. Doug and I happen to use a piece of software called Flipgrid that allows them to create short videos. We determine the length of the video, and they explain something or they pose a question. So there are a variety of different tools out there that one can implement inside a virtual environment. It's a great question, and in fact, a number of us are finding out a variety of ways of engaging our students and developing opportunities for them to work together. I happen to use WebEx in my classes, and Doug uses Microsoft Teams.
One of the things that I use with Teams is, like, for example, we did some stuff with CBR data. So we collected motion data. And so those who were remote didn't have any data. So what we did is we took data, and I'm using the TI Navigator system, the wireless calculator network in the room. And so I can take data that a group collected, and of course I've got cameras so that they can see, my remote students can see like what the students in the room are doing to collect the data. And so then what I can do with Teams is Teams has got a classroom One of the options when you create a team, you can call it a class. And then when it's a class, there's a variety of different folders and things across the top that you can put things in. And so I simply dumped CBR data into Teams, and then they can open it with their software, because if they have a TI Inspire CAS or a regular TI Inspire, it comes with a student version of the software. So my remote students can share their screen via Microsoft Teams, and I can pass data to them. Even though they couldn't be in the room to collect the data, I can pass the data for them to use. And so they just simply go into Teams under Files, double-click on that CBR data.tns file, and boom, they're using data that somebody else in the class collected. So they weren't able to collect it themselves, but they can live vicariously through watching with a camera the students collect the data. The other thing virtually that I found really useful is right now I've got about half of my students in the room and about half of them remote on any given day. So in Teams, I create a cooperative group or team for each group of students. And when I rotate them in and out of the room, depending on what day of the week they're going to be there, when they're remote, they're all remote. So in a cooperative group, they're all remote at the same time, or they're all physically in the room at the same time. And so I use my iPad, where I can pop in on my Teams app on my iPad. I use it to pop in and out of the remote groups while I send them into group discussions. That way they know I'm going to pop in and check in on them, so they know to be on task, and they know they're going to be missed if they can't blend into the background of sitting in the back row. So it's kind of nice to have two different devices going simultaneously, one for the whole class and one for me to pop in and out of the cooperative groups.
I want to comment on Wesley's contribution. Students can provide their own pictures for class analysis, and in fact, it might make sense for if you had the software on your machine to fix those points for them, you could do that if they put them in a Google Drive, if they put them in a Dropbox, some kind of mechanism that you have out there to store their data and then make it available back to them as well. It may not happen that day, but maybe you'll process that video for them and put those points on for them to do the analysis of their own, or pick 5 people and use theirs. I made up that number 5, by the way, but pick some and use those, given the students permission to do that, and then others would start to analyze the data as well. So there are a variety of things to do that. So thanks, Wesley. People can share information, whether it's pictures or data or their interpretations. And Renuka suggested that students can be asked to show their analysis on Google Slides. I think we're getting at the heart of getting people to share their contributions and their engagement with each other, and to make it a safe place for them to do that. I had a student today who did a linear interpolation, and he got it wrong, and he posted it, and he basically had just simply goofed up some computation, but not the idea. And he said, oops, my bad. And it was a perfect example of somebody making a tiny mistake and then moving forward. And in some classrooms, it seems safer for people to do that online than in a face-to-face environment. Another one, Tracy suggested something about asking for some tips and tricks for Algebra 1 and 2. I'm sure that we can shoot you some suggestions outside of this time frame. And if you would share with Mike Houston your contact information, that can be shared with you. There are tons of resources in TI's website, education.ti.com. And then there are resources all over So please email Mike if you have further questions about this. My email address is stjoh1d@cmich.edu. And you're welcome to have that. So it looks like we're out of time. Any further questions?
Dang, I think I got to take things back. I appreciate it.
Hey, thank you.
So to receive a certificate of attendance for tonight, go ahead and click the link in the chat window. Also listed as link for the documents. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Thanks so much, Dennis and Doug, for everything you put together tonight. We really appreciate it.
Thank you for giving us this chance.
Yeah. Enjoyed it.
And thanks
Take care. Good night, everybody. Thank you for coming.
Absolutely. Hope to see you back online real soon. Stay safe. Have a good day.
Bye-bye.
Bye-bye.